going to be starting with carbon disulfide. So first to draw the Lewis structure, you can figure out how many valence electrons each element has. So you can see that carbon has 4 valence electrons on the periodic table, and sulfur has 6. So there's 1 carbon, and there are 2 sulfurs. So that equals 16 valence electrons you have to use for this. So then the one that is further from fluoride on the periodic table is going to go in the center. So you have carbon in the center. On either side of it, you're going to have sulfur. And you have 16 valence electrons to share throughout it. So you just start putting them on there. And you'll realize that you need to have a double bond on either side of it. And if you add it up, 2, 4, 6, 8, 2, 4, 6, 8, that is 16 valence electrons. So you can see that it's just a straight line and there's no lone pairs. So the electron geometry is just linear. And this leads to a bond angle of just 180, which you can see over here. You can just see it's a 180 bond angle at the top. So you just sketch it. Since there's no lone pairs, it would just be the same as before. It would be different if there were lone pairs on the carbon, but there's not. You can also see that the sulfur is going to be pulling equally on either side of it, and those are going to cancel out, so there's going to be a net value there of 0, and that would make it nonpolar.
So the next one is phosphorus trichloride. So to start, phosphorus has 5 valence electrons, and there's 1, so that's 5. And then chlorine has 7 valence electrons, and there's 3 of them. So we have 26 valence electrons total. So then when drawing the Lewis structures, you first take the least electronegative element and put that in the center, which is phosphorus. And then you have 3 chlorines. So you put those equally around the central atom. And then we're gonna start by balancing the electron, or filling the octets on the chlorines. So a line like that also equals 2 dots. So you can put 3 lines around each chlorine to give them the octet. And then you can check those just by counting each line as 2 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. So that gives you an octet for all 3 of the chlorines. And then phosphorus is still missing 2 electrons. So you give it a line right there, and that equals 26 electrons, which is what you need for the Lewis structure. So since there's 3 elements along with the central atom, the shape is going to be tetrahedral. And going along with that, the bond angles are going to be 109.5 degrees. And this is because like the VSEPR properties state that the electrons are going to want to be as far away from each other as possible. So then for the sketch, since it's tetrahedral, it's going to have a different shape. So you can just have 1 chlorine here, and then 1 chlorine with the wedge that's shaded is pointing directly towards you. And then the chlorine with the dashed wedge is pointing away from you. And then based on the way the molecules organized, the dipole movements are going to be from phosphorus out. The shape of this is trigonal pyramidal, and that is due to the extra electron pair on the top of phosphorus. Unequal, so the molecule is polar.
Alright, so we're going to be making the Lewis structure for carbon tetrabromide. So first we got to get the valence electrons for it. So carbon is going to have 4 valence electrons, and bromine has 7 valence electrons. And then there's 4 carbon, not 4 carbon, there's 1 carbon, and then 4 bromide, which is going to be 32 valence electrons. So we're going to come over here and actually build the Lewis structure. So the least electronegative element is going to be the one in the middle, which is going to be carbon, and it's going to be connected to the 4 bromines. And then we're going to make sure everything's going to follow the octet rule. So we're going to make sure everything has lone pairs of electrons at the ends of it. And then carbon also follows the octet rule. And this here, each lone pair is 2 electrons. So if you count all these up, that's going to be 32, which is the valence electrons that we have to work with. So this is going to be the Lewis structure for that. The electron pair geometry is just going to be tetrahedral because there's four like elements all pulling on it at once, which is going to have a bond angle of 109.5 degrees. And then the molecular geometry is going to have the first two like this pulling normally away from it, but this is in a 3D space. So you're going to have a shaded wedge here to represent it coming more towards you as while it goes down. And then you're going to have a dashed one to represent it moving a little away from you. And then because all of the bromines are pulling equally and they're all pulling away from each other equally, the element's going to be nonpolar.
So the molecule we're going to be working with is chlorine trifluoride. In chlorine, there's 7 valence electrons, and in fluorine, there's also 7 valence electrons. Because we have 1 chlorine and we have 3 fluorine, that's going to give us a total of 28 valence electrons. So that's going to bring us over to the Lewis structure, where we're just going to set up the chlorine because it's less electronegative than fluorine. So set that in the center. And then we're going to try and set up the octets. So I'm going to put all the electrons around them. You'll notice that that's 24 valence electrons, so we have to put 2 more lone pairs at the top of chlorine, which is going to give us our electron pair geometry, which is trigonal bipyramidal. And that's going to give us bond angles of between 90 degrees to 180 degrees. The shape is going to be the exact same thing. There's chlorine in the middle, 2 lone pairs, and then the fluorines with their electrons to create the octets. So because of the bond angles, it's going to be T-shaped. And because of the shape, it's going to give it a polar characteristic. So the compound we're going to be working with is chlorine trifluoride with so the element we're going to be working with, that's not an element, that's a molecule.